Metal conducts, foam insulates, liquids flow. That's how we are taught energy behaves. But modern engineering shows something else. Sound can be forced to travel in only one direction. Heat can leave a system but cannot return. Liquids can suspend themselves in midair without containers. None of this works because of new chemistry. It works because of structure. These effects are not separate tricks. They are the same idea appearing in different forms. What you are about to see is about how modern engineering controls sound, heat, fluids, and motion using one principle: structure. We're going to see how geometry is going to act as the hidden controller. When energy behaves unexpectedly, it is usually because the paths it has been allowed to move through have been altered. If you take the same material and change only its internal geometry, energy suddenly behaves differently. Not faster, not smarter, just guided. This is the uncomfortable realization modern engineering arrived at. Energy does not care about labels like sound, heat, or motion. It only cares about available paths. For decades, engineers tried to control behavior by adding components, more insulation, more electronics, more feedback loops. That approach stopped scaling when systems became smaller, hotter, and faster. The shift happened when engineers stopped asking what something is made of and started asking how energy is allowed to move through it. That one question changes everything. So far, this sounds abstract: paths, constraint, geometry. To make it concrete, we need to watch energy fail to behave the way intuition expects. The clearest place to see that is with the waves in diffusion, because they respond immediately to boundaries. That's why the first test of geometric control appears in sound and heat. Sound is not noise, it is organized pressure waves. Waves are extremely sensitive to boundaries. In acoustic metamaterials, sound channels are shaped asymmetrically at the wavelength scale. Forward moving waves fit the geometry, backward waves do not. Nothing is absorbed, nothing is cancelled. The returning wave simply has no valid path. This eliminates echo backflow, a phenomenon where reflected sound re-enters its source and destabilizes measurements or damages equipment. Jet engine test cells already use one-way acoustic panels to prevent pressure feedback into engine inlets. Sound is not stopped by force, it is rooted by design. Heat behaves differently, but it follows the same rule. Heat spreads by diffusion, not waves. In diffusion, still obeys geometry. In phase change thermal diodes, asymmetric structures combine with the temperature-dependent material transitions. At one temperature, heat flows forward easily, and at another, the same structure resists reverse flow. No switches, no electronics. Modern-day battery packs use this to prevent thermal backflow during runaway events. Spacecrafts use it to let heat escape without allowing it to return. Sound and heat look different, but both obey the same constraint logic. What matters is not the energy type, it is the path. Sound and heat move without mass. They propagate through fields and gradients. Liquids don't get that freedom. They must conserve volume, obey continuity, and respond to force at every point. If geometry can control fluids, the most constrained form of energy transport, then structure is not just influencing behavior, it is enforcing it. Unlike waves or diffusion, liquids must obey continuity. They cannot disappear or compress freely. That makes them extremely sensitive to force geometry. In electrohydrodynamic liquid bridges, electric fields reshape internal stress distributions inside the fluid. Surface tension, electric stress, and gravity balance into a stable configuration. Remove the field and the geometry collapses. The liquid falls. The liquid here did not gain strength, its constraints changed. The same logic appears in flow phenomena. When air passes a cylindrical object, it sheds alternating vortices known as Kármán-Oettingen streets. The flow separates not because of turbulence alone, but because the geometry enforces instability at specific points. Bridges, drone bodies, and aircraft pylons are designed around this effect to avoid destructive resonance. In microfluidic systems, laminar flow dominates because channel geometry suppresses turbulence entirely. Droplets move where the geometry allows them to move. Liquids do not choose paths, they follow constraints. Flow shows how geometry guides motion over time, but geometry also leaves fingerprints that don't move at all. It determines how objects resist force, how surfaces interact with light, and how motion stabilizes or collapses. This is where structure stops being invisible and starts revealing itself directly. Force reveals geometry through stress. Aerogel, the world's lightest material, supports heavy loads not because it is strong, but because its nanoscale network distributes force across countless load paths. Metallic foams absorb impact because millions of microcells slow force propagation. Gyroid lattices, based on the non-repeating natural form, redirect stress into twisting routes solid blocks cannot match. Aircraft panels, running shoes, and rocket structures rely on this principle daily. Light reveals geometry differently. Structural color, the color without any pigment, appears because microscopic patterns interfere with specific wavelengths. Butterfly wings shimmer because of periodic ridges and not because of any dye or pigment. Ultra black coatings trap light inside forests of nanostructure, preventing reflection. No pigment is required. Color emerges from spacing. Motion follows the same rule. A swing pumps itself higher through parametric oscillation because its length changes at precise moments. An inverted pendulum balances because mass distribution and feedback geometry allow its stability to be continuously corrected. Metronomes synchronize because shared constraints redistribute energy until rhythms lock. Force, light, and motion appear unrelated. They are not. They are geometry expressing itself in different domains. By now, one pattern is impossible to ignore. Whenever energy behaves strangely, there is always a boundary involved. Surfaces, interfaces, edges, channels. That's where the geometry does its most precise work, not by stopping energy, but by deciding where it is allowed to go. At boundaries, geometry becomes interaction. Lotus repel water because microscopic pillars traps air, creating superhydrophobicity. Radiative cooling films drop below ambient temperature because layered structures reflect sunlight while emitting infrared heat to the sky. Self-healing polymers reconnect because internal networks are designed to reform under strain. At larger scales, geometry becomes energy routing. Heat pipes move vapor and liquid in opposite directions using microscopic grooves. Topological materials force electric current along protected edge states. Mechanical memory materials store deformation history inside patterned structures. Across sound, heat, fluid, light, motion, and energy transport, the same rule repeats. Energy does not respond to intelligence, it responds to constraints. Modern engineering is no longer about adding control, it is about designing paths. When you understand geometry, energy stops feeling mysterious. It stops feeling like magic. Matter is not defined by what it is made of, but how it is arranged. Structure creates behavior, and we are only beginning to understand how much of the world has been shaped that way all along. Once you see this pattern, the world stops looking like a collection of materials. It starts looking like a collection of paths. Sound follows channels, heat follows gradients, fluids follow boundaries, motion follows structure. Change the structure and the behavior changes automatically. That is why modern engineering is shifting away from brute force control and towards passive design. Not smarter machines, but better shapes. When geometry is right, energy doesn't need to be managed. It behaves correctly on its own.